Hey there, Keys Precalculus. This is section 8.2, the last 3 examples in the section. This video is entirely optional. You do not have to watch it unless you want me to just work through the last 3 examples with you. You could also just study them on your own. The last thing we learned in class was the formula for the sum of a finite arithmetic sequence. That's the first formula I have listed up here in purple on the left. S sub n, and n is just the number that you're looking for, to add all those numbers together. So if you wanted to know the sum of the first 5 terms, then n would be 5, equals n over 2 times the first term plus the last term of that partial sequence, or partial sequence. And the example we did in class is we wanted to find the sum of the first 100 integers. So because there were 100 integers in the first 100 integers, n would be 100, and the first term is 1, the last term was 100, and when we figured it all together, we figured that the sum of the first 100 integers is 5,050. But the other formulas we also learned in class was the second one here. A sub n equals the common difference times n plus c, which is just a constant. And that is how you find the nth term of an arithmetic sequence. And the c, the constant, you can find by taking the first term and subtracting the common difference, and that is the c that you would add to your arithmetic sequence. The other two, the last two terms, or excuse me, the last 2 formulas that I have listed up here in purple on the left are the recursion formulas. The first one is just saying that any term is equal to the term before it plus a common difference. And then from that we derived the alternate recursion formula, which is a sub n equals the first term plus the common difference times n minus 1. This alternate recursion formula is the one that I tend to use to find the nth term of an arithmetic sequence rather than finding c and using this one. It really does not matter which one you use to find the nth term. They're both equally as easy to use. I just automatically go to the alternate recursion formula. But you can do either one, like I said. So let's go ahead and see if we can figure out the 150th partial sum of the arithmetic sequence that begins with 5, 16, 27, 38, and 49. Those are the first 5 terms. We're going to use the first formula, this s sub n, which is s of 150, because we want to find the 150th, not just the 150th term, but we want to add the first 150 terms together. Now, we say the partial sum because this arithmetic sequence could go on to infinity or it could stop somewhere. But all we're looking for is the first to add the first 150 terms together. And you could do that by finding each term and adding them together, which would take a very long time. Or you could use this formula, s sub n equals n over 2 plus the first term plus the 150th term, or whatever term you're looking for. So we have to find the 150th term in order to use this formula. And in order to find the 150th term, I need to know the common difference. So I look at the first 2 terms and I say 16 minus 5 is 11. 27 minus 16 is also 11. 38 minus 27 is 11, and so forth as I go on. So I'm finding that my common difference is 11. And from there, I'm going to use the alternate recursion formula to find my nth term. So I'm going to say a, so 150, because that's the term I'm looking for, is the first term, 5, plus my common difference, which is 11. Then I'm going to subtract, again, the 150, because that's what I'm looking for, minus 1. And that's equal to 5 plus 11 times 149. And when I multiply all of that out, I end up getting 1,644. So my 150th term of this sequence is 1,644. But that's not what I'm looking for. I'm looking for the sum of the first 150 terms. So I have to come back up to this formula right here, the s sub n formula. So here, I'm going to say s, the sum of the first 150 terms is 150 divided by 2, just plugging in numbers here, plus times the first term, plus the 150th term, which was 1644. So if I simplify this a little bit before I multiply it out, I get 75 times 1,649, And when I multiply those numbers together, I get 123,675. And that is the sum of the first 150 terms of this arithmetic sequence. You could solve it, again, by finding each term and adding them together, but that's open to a lot of mistakes and takes forever. It is so much simpler to just use this formula. Okay, now let's look at example 7 on page, I said 569. It should be 571 here. Sorry about that. On page 571. All right, so it says that an auditorium has 20 rows of seats. There are 20 seats in the first row, 21 seats in the second row, 22 in the third, and so on. And then there's a figure. I drew the first 3 rows up here. So the first row has 20 seats, so I let my first term be 20. The second row has 21, so I let my second term be 21. The third row has 22, so the a sub 3 is 22, and so forth. The 20th row would have, we need to figure that out, so then we can find the sum of all the seats. So we are going to use this S sub n formula up here, but before we do that, we have to find the 20th term, or how many seats are in the 20th row. So the last problem I did, I used the alternate recursion formula. So on this problem, I'm going to go ahead and use the nth term of an arithmetic sequence formula, the second box here. But if we do that, we have to find what our C is and what our D is. So we know that our D is 1, right? Because there's the difference between the second and the first row is 1. The difference between the third row and the second row is 1. So we already know that our D equals 1. Now I need to find my C. So my C is just the first term, which is 20, minus D, which is 1. So C is equal to 19. Now I can use these two numbers over here in the sum formula, not the sum formula, sorry, the nth term formula, to say A sub n equals dn plus C. So A sub 20, because I'm looking for what the 20th term is D, which is 1, times n, which is 20, plus C, which is 19. So A sub 20, my 20th term, is equal to 20 plus 19, which is equal to 39. So I know my 20th term or my 20th row has 39 seats in it. So now I can find my sum. So S, the sum of all 20 rows, is equal to 20 divided by 2 times the first row, which is 20, plus the last row, which has 39. And when I simplify that, I get 10 times 59, which is 590. So now I know that I have 590 seats altogether in this auditorium. I can seat 590 people. So if you'd like, you can go back and try this problem again using the alternate recursion formula, the one I'm drawing the arrow to right here. You will find that you get the same answer. You don't have to find C first, but you get the very same thing. So you can pause the video and try that if you'd like, or you can just move on. We're going to do the next example on page 572, example 8 now, which has to do with sales. Example 8 says that a small business sells $10,000 worth of sports memorabilia during its first year of business. The owner of the business has set a goal of increasing annual sales by $7,500 each year for 19 years. So that means he'll be in business for 20 years, because the first year he had 10,000, and then for the next 19 after that, he's going to hopefully increase his business by 7,500 each year. Assuming that this goal is met, find the total sales during the first 20 years his business is in operation. And the book uses this second set of formulas that I have boxed here, that sum, or to find the, not the sum, I keep saying that, I'm sorry, to find the nth term, they use the A sub n equals dn plus C, and then they find C. So because they do that and you can study that, I'm going to go ahead and use the one I like to use the best. I'm going to use the alternate recursion formula. So we know that the first year, A sub 1, we know that they made $10,000 $10,000. Where he has a goal of increasing that number by 7,500 every year. So that means our common difference is 7,500. So our D is 7,500. So up here, to find the 20th year, how much I made in the 20th year, which I need in order to find the sum of the first 20 years, I am going to take the first, how much I made in the first year, which is $10,000, plus $7,500 times the 20th term, or not the 20th term, but the number 20 minus 1, times 19. So I have 10,000 plus 7,500 times 19. So that equals 10,000 plus 142,500. When I add those numbers together, I have the 20th year, his business made $152,500. So now I have how much I've made the first year, and I've had how much I made the 20th year, or that he made the 20th, his business made, sorry, which was 152,500. So now I can use my sum formula. So S sub 20 equals, because we're doing 20 years, 20 divided by 2 times the first year, 10,000, plus the 20th year, which was 152,500. It's a huge difference, but there's a lot of years in there. So that equals 10 times 162,500. So when we multiply that together, we get $1,625,000 is how much his business made over 20 years in sales. So hopefully, by working these 3 examples, that will help you understand how to use the sum formula for for however many terms you're looking for in an arithmetic sequence, and it should help you with your homework. Have fun!